Okay, so you can see the revision 7 prototype here, all built. It's got a solar panel and capacitor attached right now. It's stable at 4.2 volts. And I got an iPhone scanning for its signature, which should come up in just a minute. And the microscope light is powering it, and it's pretty stable. You'll see the voltage start to jump up and down once it starts transmitting. There we go. See the voltage dropping. You can see that's the device, and we'll see the voltage stabilize again in a moment once it finishes its transmission cycle. There we go, back up to normal. Now I want to show you the critical problem with revision 7, and it has to do with its ability to come back online cold start off of solar power rather than being plugged in on the micro USB. So I'll turn off the light. You can see the voltage dropping. Seems to have slowed down at 3 volts. Obviously, the LTC 4071 right there has cut out the battery from the circuit, and we're no longer powered. So the trick here is, can it come back to life if I give it some light? Yeah, see, now that is the interesting thing. It actually loses power if I give it light. Isn't that something? So this is clearly a problem, because if I give it light, it should charge. But instead, we're seeing the battery discharge all the way down to about 0.6 volts. So transistor junction voltage. There we go. Slowing down. So we are no longer functional, but we can bring it back to life by giving it a little burst of current on the micro USB port. And now it's stable again at 4.195 volts. So that problem of the cold start, I believe, can be fixed by attaching the system load, basically the BLE radio, through a PFET attached to the VBAT OK of the BQ25504. So I've ordered a board with that from Osh Park, and we'll test that out and see if it works. It's really strange that applying power causes the device to lose battery. It makes me wonder if maybe it's leaking through the buzzer, because the buzzer is connected directly to the battery. When it's charging the battery, it should only be flowing really into the the high side of the battery through the PFET's body diode into the battery. But what might be happening is the BLE radio trying to energize from the solar power might be opening up that NPN transistor somehow that's attached to the buzzer and draining the battery directly, since it needs to be connected to the battery directly. So that's another thing to consider. The battery's reached cutoff voltage again. I'm going to flip this back on. I'm going to measure the voltage on the terminal of the base of the NPN transistor that controls the buzzer when I power the light back on. So right now it's at 0. If I flip the light on, you can see it's risen to 0.468. So while this thing's trying to start up, it does in fact turn on this transistor. And that is obviously where all our battery is going. There we go. Needed a little bit more light to turn all the way on. Yep, 0.625. There we go. And it's gone. Okay, so this is the board I'm having Osh Park make, and the key differences are here and here. So I can show you really quick. The actual schematic changes. It's right here. So if you be at OK, it's put through a CMOS inverter, which is just an NMOS and a PMOS. So that should change it from being a VBAT high to a VBAT low. And that drives the system load PFET. And then there's these 2 jumper resistors they can either put the system load on VBAT or vStore. It's recommended on vStore on the data sheet, but I was having problems with vStore and the connection between vStore and VBAT, that PFET. I believe it has 6 ohms of resistance, but the problem was when it went to start blinking, so that was without the load of the buzzer. Okay, that was not going through this PFET, just the LED and the radio load during connection would shut this PFET off somehow. So that might be a problem. So that's why I have these jumpers here. So I'll probably start with it on the recommended right here, vStore, with that jumper enabled. This is the inverter, and its output signal flies down here to the gate of the PFET. The PFET gets its input from the jumpers, either vStore or VBAT, and it drives the 3.3 volt regulator. You can see this one design also is not using the BLE121 long range. This is using the BLE112 because it seems that I'm not getting an increased range, and I'm not getting increased range and connectability with the BLE121LR. And it's probably because the BLE121LR needs wings on its ground plane, so it has to come up and down. And the BLE112 doesn't need that. So I'm going to compare their connectability once I have this one manufactured, and if it's significantly better with this, because this actually is slightly longer. The BLE121LR cuts off about here, so we're adding a few millimeters in length. So if I don't have to, I don't want to add that. But if this does do better RF performance, I'm going to switch back over to this because it'll also save a little bit of BOM cost. So this is another alternate design I'm having made by Oshpark. This has 2 features. This jumper 2. This is going to allow me to measure the buzzer leakage current if there is any. So I'm just going to probe that throughout the operation of the device. Also, you'll note that there is no lithium-ion charging from the micro USB input. I'm going to have to add something here. Haven't decided what yet. But the main other reason I made this board was to test the BQ25505, which is sort of an alternate version of the solar harvester I'm using now. You can see, first of all, I don't need the inverter. I'm driving it directly from this V primary enable, and that's an active low, so I can drive the PFET directly to turn on the system load. You can see I still have the jumpers to decide if I want to drive it from vStore or VBAT. The other important thing is there's no undervoltage protection. There's no external undervoltage protection on this device. It has an internal 2-volt undervoltage protection. It does have VBAT OK, and it also does have a shipping mode of 5 nanoamp current. So that's the main reason I did it, was to lose this LTC4071, reduce part cost because it's kind of an expensive chip, and hopefully I'll be able to drive everything from that, and that would make the device a little cheaper.